Hi guys, so this one's for pre-cal, so this one is for sections 5.2. So here's another video, so for lecturing 5.2. Introduction of trigonometry. So this one is nothing special, nothing new. I'm sure you guys are pretty familiar with this already. So it's about the definition of SOHCAHTOA, and also the 6 trigonometric function with the ratio. So as you can see, that's for SOHCAHTOA, so that means sine of theta, or sine of any angle here, so let's say just theta. So that's considered opposite over hypotenuse. And then for cos, so that means cosine of theta, so that's considered adjacent over hypotenuse. And then for toa, so that means tangent of theta, so that's opposite over adjacent. Okay? So, and the function for sine, cosine, tangent, so that's what we got here for the ratio. Now what about for cotangent? Cotangent is just the reciprocals of tangent. So for cotangent of theta, so that one is considered adjacent over opposite. Okay, let me fix that one there. So that one is just adjacent over opposite. Again, it's just the reciprocal identity of tangent. And then for secant, so secant of theta, so that one is just hypotenuse over adjacent. And then for cosecant, so that one is hypotenuse over the opposite. Okay? So now, those are the ratio we're just identifying here. So anytime that I identify the ratio, make sure that you need to determine the theta, the base angle. So, because the base angle sometimes can be up here, or sometimes can be here. The 90 degree, we barely use that as the base angle. Okay? So if the base angle here adjacent, that means it's always right next to the base angle. Opposite is always the one facing across. And then hypotenuse, which is the longest leg of the right triangle here. So this one's supposed to be a right triangle. So the only time that we can use the SOHCAHTOA and also the reciprocal identity is because the triangle, it's a right triangle. So now what happens if that's something other than the right triangle? Let's say that's obtuse, a acute triangle. Are we allowed to use SOHCAHTOA? No, that would be something else. And in the future, we'll talk about, the different circumstances, something other than the right triangles. So now let's do some practice. So for each triangle, find the 6 trigonometric ratios of angle A and angle B. So that means we need to find out sine A, cosine A, tangent A, and then cosecant A, secant A, and then cotangent A. So first thing that you need to identify, so A is the base angle, so let's just shade this. So that just shows you that's a base angle. So that means adjacent is always the side length right next to the base angle. So A is the adjacent, and then 6 would be the opposite, and then 10 would be the hypotenuse. So sine of A, according to the formula, so it's opposite over hypotenuse, so 6 over 10. But don't forget to reduce the simplest form. So divided by 2 top and the bottom, so we do have 3 over 5. Make sure that you box it. And then for cosine of A, so cosine of A, so that's adjacent over hypotenuse, so it's A over 10. Reduce, so we got 4/5. And then tangent of A, opposite over adjacent, so 6 over A. Reduce, so it's 3 over 4. And now, what about for cosecant of A? Cosecant of A, it's just the reciprocals of sine of A, so which means it's just 5/3. Secant, it's just the reciprocals of cosine of A, so it's 5/4. And then for cotangent of A, reciprocals of tangent, so 4/3. Okay? Again, final solution, you just want to box it. So for the homework of 5.2, should be relatively easy. And now, let's find out the ratios for sine of capital B, so sine of angle B, cosine of B, and then tangent of B. And then after that, you want to find out cosecant of angle B, secant B, and then cotangent of B. So now this time, so the base angle has been changed. So instead of using that angle A as the base angle, so we're using angle B as the base angle. So let's just shade this one a little bit. So that's just a little indicator. So that means 6 would be the adjacent, 8 would be the opposite, and 10 would be the hypotenuse. Hypotenuse, we never change that. It's always the longest leg. So sine of B, so it's opposite over adjacent, so it's A over 6. Well, it's A over hypotenuse, A over 10, excuse me. So opposite over hypotenuse, A over 10. So which is what, 4/5? And then cosine of B, so cosine of B is adjacent over hypotenuse, so 6 over 10, which is 3 over 5. And then tangent of B, so opposite over adjacent, A over 6. So that one's give you 4/3. And then cosecant of B, just basically take the reciprocals of sine, so it's 5/4. And then secant of B, so the reciprocals of 3/5, which is 5/3. And then cotangent, reciprocals of 4/3, 3/4. Now, by comparing with what we found earlier for the ratios of angle A, so what do you guys notice? So sine of A, which is the same ratios of cosine of B. And then tangent of B, which is the same ratios as cotangent of A. So in the future, we'll talk about the identity regarding, the similarity and the difference of the SOHCAHTOA and the reciprocal identity. So we'll come up with a new identity for this. So that's going to be one of those chapters in pre-cal. Okay, so now let's see what else that we have for the rest of this. So find the exact value of the 6 trig functions of the angle theta in the simplest form. Well, this one is relatively easy. So one thing that we notice is theta, 4, and 5. So theta is the base angle. So we just want to shade that off a little bit. And then over here, so this one it's adjacent. Phi, which is the hypotenuse. So it looks like opposite. Well, that's what we need to find out. So by using the Pythagorean identity or the Pythagorean triplet, you'll see that opposite is going to be 3. So in order to find out, so let's do it this way. So a squared plus b squared equals c squared. So we got a squared, which is 4 squared, plus b squared. That's what we need to find out for b. And then c, which is 5, the hypotenuse. So 16 plus b squared equals 5 squared, 25. So 25 minus 16, then that's 9. So square root both sides, so b is 3. So that's exactly what we found. Another thing that you can figure it out by using the Pythagorean triplet, because all 3 numbers, they're all considered integers. Okay, so now let's find out all the ratios. So let's see sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and cosecant of theta. So it's pretty obvious. Sine of theta, opposite over hypotenuse, 3/5, nothing we can reduce, so just leave it. Cosine of theta, so it's 4/5. And then tangent of theta, opposite over adjacent, so 3/4. And then cotangent of theta, adjacent over opposite, so it's 4/3. Secant, hypotenuse over adjacent, so it's 5/4. And then cosecant of theta, 5/3. Okay? So now let's see anything that we have for the next part of the slide here. So find the value of the indicated trigonometric function. So we do have alpha, beta, and this one is considered 90 degree. So there are so many Greek letters: alpha, beta, sigma, gamma, lambda, omega. Okay, so things like that. So let's find out sine of alpha. So sine of alpha, again, opposite is missing here. Well, if B is the base angle, so opposite is missing. Or alpha is the base angle, that means the adjacent is missing here. By using the Pythagorean theorem, so we'll find out what that is. Excuse me. Okay, so let me just put in my phone to airplane mode. Okay, let's see. Okay, so sine of alpha. Well, sine of alpha, that one is just like 3/√, root 10. Again, alpha is the base angle, so that means opposite would be 3, hypotenuse root 10. Rationalize it, so 3 root 10 over 10. And then cosine of alpha, so now we need to figure out what Jason's psi is. So using the Pythagorean theorem, so 3 square plus b square equals root 10 square, which is 10. So 10 minus 9, so that's 1, so b square equals 1, so that means b is 1. So here, so that's 1. So cosine of alpha, so then that'd be adjacent over hypotenuse, so it's 1 over root 10. So it's root 10 over 10, after you rationalize it. And then cotangent of beta, so beta becomes the base angle, so opposite over adjacent, so, well, it's adjacent over opposite, excuse me, it's cotangent. So 3 over 1, which is 3. And then cotangent of alpha, 1 over 3, adjacent over opposite, so it's 1/3. And then secant of alpha, so secant, so root 10 over 1, which is just root 10. Okay, so let's see what else that we have. Okay, that's it. So, I mean, any question that you have, you can put up on the YouTube channel. So, put in the comment if you guys like the channel. So, please subscribe it, okay? Refer to your friends, family member, anyone that want to learn math during this critical time, the pandemic period, okay? So, looking forward to see you guys again. Take care.